Hello everyone, welcome to my channel. In this video we'll be learning how to analyze horizontal frame system by using Cantilever method. Please don't forget to like, comment and subscribe to stay updated for more civil engineering tutorials. So today let's start with these problems. Our problem states that apply Cantilever method to determine shear force and bending moment, and then to draw bending moment diagram and shear force diagram, whereby stiffness stiffness of the material is kept constant. We've given the frame here, which have horizontal forces and its span. So when we analyzing horizontal frame system by using Cantilever method, the first step is to introduce imaginary hinge at the point of inflection point. The point at the center of inflection point. Inflection point is a point of zero moment, and this point occurs at the center of the system. This is as an imaginary point. Imaginary point. Let's label it with small letters. Let's say A, small b, small c, small d, E, F, G, H. As the next step is to introduce levels. Along this imaginary hinge point. Let's say this is level 1, level 2, 2. After that, by using Cantilever method, the next step is to locate the centroid of the column area. Let's say the centroid of the column area is at this region. This is neutral axis of the centroid, whereby the span of this frame system from this to this was 8 meters, from this to this was 10 meters. So how centroid is obtained? Centroid of the column area is obtained by summation of area times distance over total area. Therefore, centroid will be area of the column member times its distance. For this column member, it will be area 1 times zero distance at this member. There is zero distance of the column member, plus area 2 of this column member times distance from this point to this point, which is equal to 8 meters, plus area 3 over distance from this point up to this column member, which is its distance will be 18 meters, over total area 1 plus area 2 plus area 3. Therefore, the centroid will be but area 1 is equal to area 2 is equal to area 3, which is equal to area. The area of the frame system remain constant. Therefore, our equation of centroid will be 8a plus 18 area over 3a over 3a. Let's calculate this by using calculator. 8 plus 18 over 3 will get 8.67 meter. Area and area cancel out. Therefore, the centroid of this column area is 8.67 meter. Since Cantilever method states that normal forces are direct proportional to the respective distance of the column member from the center of the column area. Therefore, the distance of this column member from the centroid for this column member, its distance from the centroid will be equal to, let's say this is x1, which is 8.67 meter. And the distance of this column member from this column member to the centroid will be x2, which is equal to, from this point to this point is 8.67, and from this point to this point to this column member is 8. So in order to obtain the distance from this point to the centroid, we take 8.67 minus 8. It will remain 0.67 meter. And the distance of this column member to the centroid from this point to this point is 10 meters. So in order to obtain the distance from column member, this one, to the centroid, let's say this is x3, it will be 10 minus from 10 minus 0.67, which is equal to 9.33 meter. Those are the distance from the column, from the respective member to the centroid of the column area. After that, the next step is to cut the section by considering levels. So by considering level 1, by considering level 1, it will be in this way. It will be in this way. This is VG for level 1 at this point. We have cut it at this point. VG. This is NG. Normal forces. VH. NH. Normal force at H. This is VD at this point. VD. And the normal forces is always, this is centroid. This is neutral axis of the centroid. This is the center. Normal forces is always directed towards the center of the centroid. So normal force at this point, it will be in this direction. This is normal force at point D and D. And the distance from NG to this point is x1, which is equal to 8.67 meter. And the distance from NH to the centroid is x2, which is equal to 0.67 meter. And the distance from the centroid to ND is x3, which is equal to 9.33 meter. After that, according to Cantilever method, which is its normal force is direct proportion to the respective distance of the column member from the centroid of the column area. After removing proportional constant, it will be in this way, xi. This how k is obtained. K is obtained by summation of fi hi over summation of xi square. This is horizontal force, which was 20 kilonewton, and the distance from this point was from this point to this point was 4 meters. So here will be 2 meter, 2 meter, 2 meter, 2 meter. So the distance from this point to this point is 2 meter. Is 2 meter, which is h 2 meter. So for this case, let's say is K1. K1 we have only one horizontal force, which is 20 kilonewton. So here will be force 1 times h over x1 square plus x2 square plus x3 square. K1 will be force 1 is 20 kilonewton times 2, which is 8 over x1. x1 is 8.67 square plus 0.67 square plus 9.33 square. Therefore, by using our calculator, is 40 over 8.67 square plus 0.67 square plus 9.33 square. K1 will be 0.246. Okay, this is for level 1. For level 2, now after getting the value of k, now come to this equation, normal for in order to get the normal force for this column member and this column member. So according to this formula, Ni is equal to Kxi. Therefore, Ng will be K, which is 0.246 times x1 from this point to this point, which is times 8.67, 0.44546 times 8.67, it will be equal to 2.13 kilonewton. NH will be 0.45 K times x2 times 0.67. It will be 0.67. It will be 0.16 kilonewton. ND since it is in opposite direction, so it will be negative. So it will be 0.246 times 9.33. It will be equal to calculation 9.33. We will get 2.30 kilonewton. Now let's consider level 2. Level 2. Level 2, it will be in this way. Here we have horizontal force, which was 20 kilonewton. Here was 40 kilonewton. This is EVA, normal force at A. VB, NB. This is VC, NC in opposite direction. NC. This is centroid. Neutrox is of the centroid from this point to this point is final was x1, which is 8.67 meter. From this point to this point, x2, 0.67 meter. From this point to this point is x3, which is 9.33 meter. 9.33 meter. Okay. Now, according to Cantilever, which says normal force is directly proportional to its respective distance, which is xi, but k is equal to summation of Fy hi over summation of xi square. From this point to this point was 4 meter, and from this point to this point was 2 meter. Therefore, K2, it will be force 1 times its distance up to the center. From this, its distance will be from this force up to the center of the centroid, which is its distance will be 6 meter. 4 plus 2, it will be 6 meter. Force 1 as well, therefore it will be 20 times 6 plus this horizontal force, its perpendicular distance up to the center of the centroid is 2 meter. Is 2 meter. So it will be 40 times 2 over x1 8.67 square plus 0.67 square plus 9.33 square. Okay, it will be times plus over 8.67 square plus 0.67 square plus 9.33 square. It will be 1.230. So, therefore, normal force at point A, it will be K times x1, 1.230 times 8.67 is equal to 8.67 will be 10.66 kilonewton. NB, it will be 1.230 times 0.67. 0.67, it will be 0.82 kilonewton. And C, since it is in opposite direction, so it will be negative 1.230 times 9.33 is equal to negative 11.48 kilonewton. The next step, after getting the normal forces, the next step is to calculate the shear force of horizontal forces the shear force of horizontal members. The shear force of horizontal members. The shear force at this point. 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 This is a shear force of horizontal members at the point of inflection point. So the shear force, it will be obtained by taking the equilibrium of shear, by taking the equilibrium of vertical forces. Okay, let's calculate the shear force of these horizontal members. Consider for level 1, this was the rigid joint G. here was VG, here was NG. Take this rigid joint by cutting these levels and this point. NG we have calculated here, NG was 2.13. Here, this is VF, NF. Our target to calculate this shear force of horizontal members. Therefore, by taking the equilibrium of vertical forces, summation of vertical force is equal to 0. All upward will be positive, downward force negative. VF minus NG is negative since it's downward, minus 2.13 is equal to 0. VF, it will be 2.13 kilonewton. Also consider this so as to get a VE. This is VG, NG, VH, NH, which is equal to NH was 0.16 and the NG was 2.13 kilonewton. Here was VI, VI. This is NI. So, by taking summation of vertical force is equal to 0, so as to get shear force of this horizontal member, positive, negative. Here, VE, upward is positive, minus 0.16 is equal to 0. VE, it will be 2.13 plus 0.16. It will be 2.29 kilonewton. Also consider for level 2, it will be in this way. It will be in this way. For level 2, here was 20 kilonewton, 40 kilonewton, was VA, NA, which was NA is 10.66. This is VF. VF we have obtained here, which was 2.13. This is NF. VI, this one. VI, this one. VI at this point. Okay, this is NI. So to get VI, we take summation of vertical force is equal to 0. Positive, upward, downward, negative. So VI plus 2.13 minus 10.66 is equal to 0. VI, it will be 10 minus 66 minus 213. It will be 8.53 kilonewton. Also consider this level. Here was 20 kilonewton, 40. This was VA, NA, which was and here we choose 10.66. This is VB, NB, NB was 0.82. This is FI. Here was VI. No, VF. VF was 2.13. Here was, this is VJ. VJ at this point. At this point, VJ. Okay. And J. So as to, in order to obtain a VJ, we take the summation of vertical force is equal to 0, upward positive, and downward negative. So Vj plus 2.13 minus 10.66 minus 0.82 is equal to 0. Vj is equal to 10.66 plus 0.82 minus 2.13. We'll get 9.35 kilonewton. All of those are the shear force of horizontal members. So the next step is to calculate the bending moment of this horizontal, the moment of this shear force of horizontal members. So the bending moment is obtained by shear force times distance from the point of inflection point to the ridge joint, So in order to obtain MF, it will be VF, shear force at F times its distance from the point of inflection point to the ridge joint, which is from this point to this point is 4 meters. So this from the point of inflection point to the ridge point, it will be 4 meters. Therefore, VF, it will be VF times 4 meters. VF was 2.13 times 4. It will be 2.13 times 4. It will be 8.52 kilonewton meter. ME, it will be VE times VE. From this point to this point is 10 meters. So since moment is obtained by taking the shear force times distance from the inflection point to the ridge joint, it will be 5 meters. So 10 over 2, it will be 5. So VE, which was 2.29 times 5, 2.29 times 5, it will be 11.545 kilonewton meter. Okay, now is VI. MY, it will be VI times from this point to this point, VI is at the center, so it will be 4 times 4 is equal to VI is 8.53 times 4. 8.53 times 4, it will be 34.12 kilonewton meter. MJ, it will be VJ times 5. VJ was 9.35 times 5. 9.35 times 5, it will be 46 or 0.75 kilonewton meter. All of these are the bending moment of horizontal members. After obtaining this bending moment, the next step is to draw bending moment. Bending moment diagram. Bending moment diagram of the frame system. It will be in this way. It will be in this way. Here was inflection point for point A, point B, point C, inflection point D, E, F, G, H, I, J. So when you in order to draw the bending moment diagram, let's consider this one so as to draw well and clearly. Let's consider this so as to obtain clear concepts for drawing bending moment diagram. This is when we cut the section that is this member, internal forces are produced, the shear force and the bending moment. So the shear force, the bending moment is in this direction. According to this here was F, so it will be bending moment MF. This is at equilibrium. Even at this rigid point, at this point at point G, if the member is cut, a section this way, shear force it will be in this direction. It follows the shear force is always opposite of the horizontal forces, which was here 20 kilonewton. So this will be the shear force at point G. At equilibrium in order to be at equilibrium, another shear force will be in this direction. So the bending moment at G, this is mg. For equilibrium, another bending moment, it will be in this direction. This is mg. Even at this hinge joint, it will be shear force. Its bending moment diagram, it will be ME. All of these are in equilibrium. So we're having the bending moment at MF. During drawing the bending moment is drawn to the tail of the moment. This is MG. No, MF. This is MF. And here we're having MF, bending moment at F. So the tail of the MF is at this region. So its bending moment diagram, it will be at this region. Since the tail is at this region, so its bending moment diagram, it will be in this way. So for equilibrium, this moment we prolong so as to be in equilibrium. This is bending moment diagram 8.52. Similar at this point. ME is at this region and its tail is bending moment is drawing to the tail. The tail is at this region, so its bending moment it will be at this region. So its bending moment diagram, it will be this way. For equilibrium, this member, the bending moment will be prolonged this way, so as to be in equilibrium. This is ME, which is 11.45. Even at this point, at this point, at point, at point E, at point I, shear force are in this way. So its bending moment diagram it will be in this way and this way. So as to be in equilibrium. This is My. This is My. Even at point J, this is bending moment Mj, Mj, Mj. So always the bending moment is going to the tail. The tail at bending moment at I is at this region. So its bending moment diagram it will be in this way. It will be in this way. For equilibrium, we shall prolong this way. So My was 34.12. Similar to this point J. Mj is its tail is at this region. So its bending moment diagram it will be at this region. For equilibrium or bending moment, we shall prolong this way. This is bending moment of Mj, which is 46.75. This is a bending moment diagram of horizontal members. So to obtain bending moment of vertical members, bending moment of vertical members is obtained by taking the equilibrium at hinge joint. Hinge joint is at this point. This is this one. This has a hinge. No, this has a ridge joint. So the shear force as the bending moment of vertical members is obtained by taking the equilibrium at the ridge joint. At this one, this was BC. This was ridge joint D, E, F, G, H, I. So this calculates the bending moment diagram of vertical forces. Vertical forces at this point is this one, and this one. So let's start at ridge joint G. Summation of moment at G is equal to 0. All in this clockwise direction positive, anti-clockwise negative, anti-clockwise negative. So at this point, Mg is clockwise direction, so it will be positive minus MF. MF is the anti-clockwise direction, is equal to 0. So Mg is equal to MF, which is MF is 80.52. Therefore, Mg is 8.52. Mg is this one. As the tail for Mg is at this region. Mg is at this region, so it's bending the tail of Mg is at this region. It's bending on diagram. It will be in this way. It will be in this way. For equilibrium, this member we shall prolong this way so as to be in equilibrium. So Mg it will be 8.52. This is bending moment of Mg. Now let's consider at the ridge joint F. Summation of moment at ridge joint F is equal to 0. Clockwise positive, anti-clockwise negative. So at this point also, this is MH MH. At this point, MH, so the equilibrium at this point, we're having the bending moment of MH, MF, and ME. So MH is the clockwise direction, so it's positive MH. MF is in anti-clockwise direction minus MF plus ME. ME is the anti-clockwise direction, so it will be negative here, is equal to 0. So MH, it will be MF plus ME, which is MF was 8.52 plus 11.45. 8.52 plus 11.45. It will be 19.97. So the bending moment at H is this one. Since bending moment at H is tail is at this region, so its bending moment diagram will be look like this one. For equilibrium, we shall form this way. This is the bending moment of H. So this is 19.97. 19.97. Let's come at this point. Summation of moment at E is equal to 0. Clockwise positive, anti-clockwise negative. So here we're having internal forces bending moment in this way at equilibrium. This is MD, which is in equilibrium. So at this point, we're having ME and MD. So equilibrium at this point. So MD is in clockwise direction. It will be MD. ME anti-clockwise direction minus ME is equal to 0. MD, it will be equal to ME, which is 11.45 kilonewton meter. So the bending moment at this point is the tail is at this region. So it will be the bending moment is drawn at the tail. The tail is at this region. So the bending moment will be in this way. For equilibrium, we shall form this way. So the bending moment at point D, it will be like this one, which is 11.45. 11.45. Similarly to this point, we shall do similar to that point. Okay, let's take summation of moment at point H so as to get the bending moment at A. Here, this is VA, bending moment at A, MA. This is MA. Take summation of moment at H is equal to 0. With joint H, positive clockwise and clockwise negative. So at this point we have MA clockwise direction, MA plus MG clockwise direction minus MG is equal to 0. MA, it will be equal to MG minus MG. No, this is MY. It will be MY minus MG. MY is 34.12 minus MG. MG is 8.52. Therefore, MY is equal to 35.34.12 minus 8.552. It will be equal to 25.6 kilonewton meter. Okay. The tail of this moment is at this region, so its bending moment it will be drawn this way. For equilibrium, we shall prolong this way. This is bending moment of point A, which is 25.6. Let's go at point B. Let's take summation of a moment at point I. Also here there is internal forces. This bending moment of B, for equilibrium it will be MB also. Okay, let's take summation of a moment at point I is equal to 0. Summation of a moment at point I is equal to 0. Here we have MB clockwise direction minus My in anticlockwise direction minus Mj plus Mh is equal to 0. So Mb it will be My. My is 34.12 plus Mj. Mj is 46.75 minus Mh. Mh is this one. Is 19.97. So Mb it will be 4.12 plus 46.75 minus 0.97. Mb it will be 60.9. So the tail of MB is at this region, so its bending moment diagram it will be drawn at this region. For equilibrium, we shall prolong this way. So this is MB, which is 60.9. Okay, let's go at this point C. Also there is here internal forces. This is MC. It's 6 summation of a moment at point C, no at point D, at ridge joint D. Is equal to 0. So clockwise positive and clockwise negative. So MC, clockwise direction, MC minus MJ is in anti-clockwise direction, plus MD, which is clockwise direction, is equal to 0. So MC it will be MJ minus MD. MJ is 46.75 minus MD. MD is 11.45. So MC it will be 46.75 minus 11.45. It will be 65.30 kilonewton meter. So its bending moment diagram, its tail is at this region, so its bending moment diagram will be in this way. For equilibrium, we shall prolong this way. This is bending moment point C, which is 35.3 kilonewton meter. This is a bending moment of that frame. Now let's draw the shear force diagram. The The shear force, first of all, we have calculated the shear force of horizontal members. Now, let's calculate the shear force of vertical members. The shear force of vertical members is obtained by taking the bending moment, the bending moment of vertical members divided by distance from the point of inflection point to the ridge joint. So, the shear force of vertical members is obtained by bending moment of vertical members over distance from the point of inflection point to the ridge joint. So Vg it will be its bending moment for this case is 8.52 over distance from this point to this point is 4, and from this point at point G to ridge joint is 2 meters. So it will be divided by 2. 8.52 divided by 2. It will be 4.26 kilonewton. Vh, its bending moment is 19.97 divided by 2. It will be divided by 2. It will be 9.99 kilonewton. Vd, it will be this one. Its bending moment diagram is this one. So 11.45 over its distance from this point to this point is 2. So it will be 11.45 divided by 2. It will be 5.73 kilonewton. Also, its bending moment diagram is this one and this one. So it will be obtained by taking this moment divided by its distance from this point to the ridge joint. So it will be 25.6 over 2. 25.6 divided by 2. It will be 12.8 kilonewton. Vb, it will be this moment 60.9 over 2. It will be 60.9 divided by 2. It will be 30.45 kilonewton. Vc also, it will be this moment divided by its distance, which is 2. 65.3 divided by 2. 65.3 divided by 2. It will be 17.65 kilonewton. All this as a shear force of vertical members. The shear force of horizontal members we have obtained, which is this one. Now let's draw the shear force diagram. The shear force diagram of this frame system. Shear force diagram. The frame system was in this way. Here was in joint point A, in joint point B, point C, point D, point E, point F, imaginary range point G, imaginary range point H, point I, point J. During drawing the shear force diagram, the case to consider is you choose or select which side will be positive between this member. For this member, it will be negative side, positive side, negative side, positive side, negative, positive. Since the shear forces are all positive, even if for horizontal members, we can select, since all are positive, we can select this region will be positive, downward also it will be positive. Therefore, the shear force of point F is 2. This is shear force of point F was 2.13, and the shear force point E was 2.29. Okay, the shear force point I was 8. The shear force point I was 8.53, and the shear force point J was 9.35. Now the shear force the shear force point. Now let's draw the shear force point G. The shear force point G was 4.26. The shear force point G this way was 4.26, and the shear force of point H is, remember, its shear force was this one. It was 9.99, and the shear force point D was 5.75. This is positive, and its member is this one. So it will be drawn positive side in positive side like this way, which was 5.73, and the shear force point A was 12.80, and the shear force point B was 30.45, and the shear force of point C, was 17.65 kilonewton. This is a shear force diagram of the frame system. So we have drawn both bending moment diagram and shear force diagram. Thank you for watching this video. Please don't forget to like, subscribe to stay updated for more civil engineering tutorial.